So today we are moving to the second part of the same chapter, numbers, right? Previous part was about understanding numbers, different types, their properties, and a lot of basic things like HCF, LCM, like divisibility tests, like prime, composite, co-prime, right? Even odd, all of that, right? So today we are going to learn concept-wise a really important thing, that is prime factorization, and a lot of its applications to solve a few things, okay? So what is prime factorization in the first place? Are you aware? Yes. All right. So what is prime factorization? Yesterday we learned what factors are, right? Factors are basically numbers which divide the given number, right? तो हम क्या कर रहे थे, कल कोई भी नंबर हमको बोला था, let's say for example the number is 24. So अगर हमको कोई भी नंबर बोला था, let's say 24 बोला है, we were like 24 is 1 into 24, 2 into 12, 3 into 8, 4 into 6. And this is how we derived कि 1, 2, 3, 4, 6, 8, 12 and 24 are factors of 24, right? What are prime factors? Prime factors are basically, instead of factorizing the given number in any random numbers, जो भी numbers मिल रहे थे हम सब में factorize कर रहे थे, उसकी जगह पे when we represent a given number as a multiple of only prime numbers, we call it prime factorization. ठीक है? मतलब ये 24 को I'm writing as 2 is prime number, right? 2 12s are. 12 I'm writing as 2 6s are. 6 I'm writing as 2 3s are. This is basically 2 into 2 into 2, that is 2 cube into 3 raised to 1. So I can represent my number 24 as 2 cube into 3 raised to 1. 2 is a prime number, 3 is a prime number. 2 के power, 3 के power के multiple में I am able to write number 24. So this is prime factorization of 24. Fair? Understood? Right? So इसी के हिसाब से now this is a very important thing and we are going to use it. We're going to see कि how splitting a number into prime factors has multiple applications. But before that, I would just want you to prime factorize a few numbers. So prime factorize 72, prime factorize 180. Tell me what are your answers? How to solve this? 72. 72 can be written as 2 into 36. And this is nothing but 4 9s. अगर हम लिख लिया तो 2 square and 3 square आ जाता है. So overall 72 is 2 cube into 3 square. Yes, give me a thumbs up if you have clarity on this. Yeah. Similarly, see, ideally you can keep forming this forest of root factors, right? 2 into 36, then 36 is 2 into 18, then 18 is 2 into 9. ऐसे तुम जा ही सकते हो. ये short term मैंने निकाला. वैसे 180 can be written as 18 into 10, where 18 is 2 9s are and this is 2 5s are. So overall it will become 2 square into this is 3 square into 5 raised to 1. Quickly we found out, right? So this is prime factorization of 180. Correct? 2 square into 3 square into 5 raised to 1. Okay. What are prime factors of 96? Similarly, what do we do is, how do we divide this? 16 6 भी लिख सकते हैं, है ना? जैसे भी, which however it favors. So this is 2 raised to 4. This is 2 3s are. So then overall it becomes 2 raised to 5 into 3 raised to 1. Any confusion or do you have clarity? Pretty easy, right? Prime factorization, है ना? So 420 is how 42 into 10 I'll just write. This 6 7s are. This is 2 5s are. So now this is 2 3s are. So overall 420 is basically 2 and 2 here. That is 2 square into 3 into 5 into 7. This is 420. Okay. So this is how we ended up finding prime factors of the given numbers. All right. Now, once you prime factorize like this, what are different applications of factorizing number like this? Okay, let us have a look at it. First application is, once you prime factorize, you can find total number of factors. What I mean by that is, let's say there's a random number n given to you, and this number n can be written as, can be prime factorized, right? So 2 raised to power a into p1 raised to power d into p2 raised to power c into p3 raised to power d into so on, ऐसे लिखा जा सकता है. Where p1, p2, p3 ये सब क्या है? Odd prime number है. Fair? Right? मैंने 2 अलग से क्यों लिखा? Because 2 is the only even prime number, है ना? तो कोई भी नंबर का अगर 2 का मल्टीपल होगा तो 2 raised to something आएगा, तो 2 का मल्टीपल नहीं आएगा तो a की वैल्यू 0 आएगी, 2 raised to 0 is 1, like that. but P1, P2, P3 are all odd prime numbers. So any number n can be written as a multiplication of prime numbers like this to prime factorization. Yes or no? Yes. Very good. So now once I know this, then I can say the number of factors, total number of factors of this number n is given as nf. Number of factors of n is given as a plus 1 into b plus 1 into c plus 1 into d plus 1 and so on. Very, 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 very important to know. Okay? What do you mean by number of factors? Basically, number of factors matlab hai, let's say 24 as a number. You take 24 as a number, right? Wait, I just write here. Let's say you take 24 as a number, and we saw that it can be written prime factorized as 2q into 3 raised to 1. हमने prime factorization इसका starting of the class देखा कि it can be written like this. So basically, it is written in the form of 2 raised to 3, 2 raised to a into p1 raised to 1. So whole point is the number of factors of 24 will be this 3 plus 1 a plus 1 into b plus 1, which is 4 2s are 8. And if you actually look at the list of factors जो हमने starting of the class निकाला था इसका, स्टार्टिंग ऑफ द क्लास अगर हमने 24 के फैक्टर्स देखे थे 1 2 3 4 5 6 7 8 फैक्टर्स ही थे, राइट? सो इफ अ नंबर इज रियली जाइगेंटिक, रियली बिग, and you need to find out how many factors does that number have, we can use the following thing. जैसे ये अभी let's say we have number like 420. There is a number like 420 and you want to know how many factors does 420 have. How many factors does 420 have? Okay. Now, if you have to find how many factors does 420 have, what are you going to do? You know that this is written in the form of 2 raised to a into p1 raised to p2 raised to c, p3 raised to d, and so on. So, number of factors of 420 are going to be 2 plus 1. फिर यहाँ पे 1 plus 1, 1 plus 1, 1 plus 1. This will be 3 into 2 into 2 into 2, which is 24. So, number of factors of 420 is 24. Did you understand what number of factors as a formula is for? Right? So this is how we can find number of factors. Now, ऐसे ही अगर हमें निकालना है, okay, ऐसे ही let's say we want to find out number of odd factors. Number of factors of this number which are odd. है ना? Like for 24, the factor was also 2 was also a factor, 3 was also a factor, 4 was also a factor. But odd factor will only be 3. 2 and 4 are even factors, right? If you want to find odd factors, what do? 2 का जो power है a, उसका component we basically remove and we just write b plus 1, c plus 1, d plus 1. सिर्फ odd number के factors हम लेते हैं, ठीक है? So then number of even factors becomes total number of factors minus number of odd. ठीक है? Let's say total number of factors are 8 and we find out that the odd factors are 2. So that means 8 minus 2 remaining 6 are even numbers as the factors. Fair? Understood? ठीक है? ये एक सेट ऑफ फॉर्मूले है. मस्ट नोट, मस्ट रिमेंबर द लॉजिक. करेक्ट? सॉर्टेड? है ना? ओके, वेरी नाइस. लेट अस मूव टू द सेकंड बिट ऑफ इट. नेक्स्ट बिट इज sum of factors. Sum of factors as in for 24 we found 1 2 3 4 6 8 12 and 24 were the factors, right? Now I want to add all of these factors. I'll be like, okay, if I add it, what is the sum? If I add all of these factors, what is the sum? So this sum also can be found out using the prime factorization. Same, your number n is written as, okay? Same, your number n is written as 2 raised to a into p1 raised to b, p2 raised to c, p3 raised to d, and so on, where p1, p2, p3 are all odd prime numbers. So at that time, sum of factors, sum of all factors is given by 2 raised to a plus 1 minus 1 upon 2 minus 1. Okay? p1 raised to b plus 1 minus 1 upon p1 minus 1. p2 into c plus 1 minus 1 upon p2 minus 1, and so on. This is the formula. इसी में ही अगर हमें odd numbers का sum निकालना है तो what are we going to do? We are going to not take the 2 वाला factor and we're just going to start from here. p1 b plus 1 minus 1 upon and so on. And if we have to find sum of even, So that will be sum of all factors minus sum of factors that are odd will give you sum of even. By the way, even ke liye there's a separate formula that exists, but I deliberately don't teach you because it's an unnecessarily complicated new formula to remember. And इसका application इतना आता नहीं है कि it's going to be like oh this thing. ठीक है? So you rather remember it like this and make quick calculations, right? I would rather encourage that. Fair? Okay. Okay, so if you had to apply this on 24, let's say, if you had to apply this on 24, how would you be like, okay, the sum of all factors of 24 is given as 2 raised to 3 plus 1 minus 1 upon 2 minus 1 and 3 raised to 1 plus 1 minus 1 upon 3 minus 1, which basically becomes 2 raised to 4 is 16 minus 1, 15 by 1 into 3 square is 9. This is plus, na? 1 plus 1. 3 square is 9 minus 1 is 8 divided by 2. So 15 fours are 60. देखो तो सारे फैक्टर्स का सम 1 plus 2 plus 3 plus 4 plus 6 plus 8 plus 12 plus 24. यही थे ना तुम्हारे, यही थे तुम्हारे फैक्टर्स ऑफ 25. Do they all add up to your this thing 60? See 25, 30, 40, 50, 60. It does, right? So this is how you end up implementing the formula of sum of all factors. Yes, I hope you wrote it down. Second application is finding sum of all factors. Can I move ahead? Very good. So now third thing is product of factors. All the factors are given to you and now you're supposed to find the product of factors. ठीक है? कि जैसे अभी 24 दिया है and 24 के सारे factors हैं and I have to find product of all of these. How do I find it? Okay. So then there is a trick to understand this. See, product at the end, इन दोनों का multiplication 24 है. These two are also 24. These two are also 24. These two are also 24. Right? So at the end, out of the 8 factors that exist, 2 combined, out of the 8 factors, 2 combined form 4 pairs. And every pair is 24. So the answer should be 24 raised to 4. Right? So, point B, product of factors is basically whatever the number is there, raised to power number of factors divided by 2. This is what we did, right? If 24 has 8 factors, 2 combined, 2 multiplied to each other form 24. There are 4 pairs, right? So number of factors divided by 2. 8 divided by 2, 4. So number of factors divided by 2 is the number of pairs. है ना? और उस हर एक pair का multiplication 24. So this becomes 24 into 24 into 24 into 24. 4 times. So whatever the number n is given, that raised to power. And just in case it's a perfect square, you will be like, it is root n raised to power. Because n raised to root 2n, 1 by 2 n यहाँ पे. That is it. So this is product of factors. Fair? Understood? Okay? This is as simple as it can get. So these are direct applications. Number of factors, sum of factor, product of factors. Okay? तो ये एक application था. Now what do we have next? Next we have application in terms of perfect squares. Okay? What does perfect square mean? What does perfect square mean? Perfect square mean basically what happens is, let's say you're given any prime number. We will take 24 again because that is what we are doing, right? The whole point is to make this a perfect square. To make given number is 24. To make 24 a perfect square, you will need prime factorization in such a way that the powers of each of the value is even number, right? Because 2 will combine and form, है ना? मतलब जैसे अगर यहाँ पे 2 raised to 4 है और 3 raised to 2 है, then this becomes a perfect square and then it will be इसका square root हो जाएगा 2 square into 3, right? इसका square हो जाएगा 2 square is to 3, है ना? So basically we're trying to say that if we want to make a number a perfect square, we will need every prime number's exponent to be even, right? We will need every prime number's exponent to be even. Only then it can become a perfect square. So the kind of question that is asked here is, the kind of question that is asked here is, what is the smallest number to multiply (24), let's say, to make it a perfect square. अगर मुझे 24 को perfect square बनाना है, what is the smallest number I'll have to multiply with 24? So then you're like, okay, I know 24 is 2 cube into 3 raised to 1. For 24 to be a perfect square, I will need the exponents to be even numbers. So basically, I'll have to multiply this 1, 2, and I'll have to multiply this by 1, 3. That is when it will become 2 raised to 4 into 3 square, which definitely is a perfect square. So I had to multiply 24 by 6. I had to multiply 24 by 6. And that is how it became a perfect square. It became 144, which is a perfect square. Do you understand the logic here? Do you understand the logic? So one application of prime factorization is to solve questions like this. What is the smallest number that will actually multiply to the given number n to make it a perfect square? So the funda is that we'll have to make exponents exponent should be even or exponent should be multiple of 2. Yes? Clarity? Very good. Now similarly, there's a perfect cube while application also. For perfect cube, what will happen? Here we will need the exponents to be multiples of 3 ना, है ना? Multiples of 3 में हम exponents लगेंगे. Same question, ठीक है? Smallest number to multiply 24 so that it becomes perfect cube. So that it becomes perfect cube. So I'm like, okay, I know 24 is 2 cube into 3. This it's a cube itself. This is not. So I'll have to multiply this thing by 3 square in order to make it 3 cube. And that way it will become 2 cube into 3 cube. And then this will be a perfect cube. So I'll have to multiply 24 by this 3 square, which is 9. है ना? Which is 6 cube. It became 6 cube, right? Definitely 2 cube into 3 cube. The cube root uska 2 into 3 hoga. So I'll have to make the exponents. And right now here exponent was 3 already, which is a multiple of 3. Here I'll have to make the exponent as multiple. Fair? Understood? Yes? Very, very good. Right? So these are next two applications. That what number should you multiply to a given number in order to make it either a perfect cube or a perfect square. Okay? So here also your prime factorization helps. Now, what's next application? Prime factorization also helps you find the HCF and LCM of two numbers. Let's say the two numbers that are given to you is 24 and 72. 24 is 2 cube into, actually let's take some better examples. Yesterday we solved for 108 and 180. Right? Yesterday we solved HCF and LCM for 108 and 180. So tell me prime factorization of each of these. Tell me prime factorization of each of these, 108 as well as 180. Okay. So this is 2 square into 3 cube. That is 27 fours are. Fair. And what is 180? It is 2 square into 3 square into 5. Right? Which is 36 fives are. Right? So this is how we prime factorize, right? Now, the whole point is note. It's the same thing how we calculate HCF, LCM earlier. It's the same thing, but just note here. So basically, HCF, right, is the least common power. HCF is generated by least common power. What do I mean by it? Least common power of 2 is 2 itself. 3 का least common power क्या है? 2, because 3 cube है, यहाँ पे 3 square है. And 5 का least common power क्या है? 0, ऊपर 5 raised to 0 है, मतलब nothing. 1, so this is 2 square into 3 square. This is your HCF, right? And your LCM is the highest common power. In prime factorization, what is the highest power common power? 2 का 2 square है, 3 cube और 3 square में से 3 cube लेंगे हम, and 5 raised to 0 and 5 raised to 1 में से 5 raised to 1 लेंगे हम. Now if you multiply this, you get 540, and that is your LCM. So this is how you can use prime factorization to also find HCF and LCM. Understood? It's similar to how we did it yesterday. Just a different way of looking at it. Now, this is the sixth application. Now we are getting a bit more serious. अभी तो ऐसे warm up था, theory था. Now we are getting a bit more serious, more interesting applications of prime factorization. So here the application of prime factorization is finding number of trailing zeros. What is a trailing zero? Trailing zero is a zero that comes at the end. Like let's say a number is, how many trailing zeros it has? Only one. Trailing zeros are the zeros that come at the end, right? So now if you have to find how many trailing zeros a certain this thing has. Okay, let's say they've given you a question. Find number of trailing zeros in 32 into 33 into 34 into 35 into 36 into 37 into 38 into 39. They have asked you to find, if we multiply these numbers like this, how many number of trailing zeros will be there? So how do we find that? How do we find it? Think about it. The way to think here is, see, zeros, the trailing zeros are going to be formed when we have 2 into 5 as a multiple. 2 into 5 makes 10, and one pair of this equals to one trailing zero. Yes or no? 5 to the 10 होगा, और जब 5 to the 10 होगा, so 10 का zero पीछे लग जाएगा, and that is where you will get a trailing zero. Each pair will contribute to 1, 0. So if I have to do this, here's how I'm going to find how many pairs of 2 into 5 exists. So for that, what I'll do is, I'll prime factorize each of these terms. I know for sure this is 2 raised to 5. There is no 2 or 5 here. There is 2 into 17. So 1, 2 will come. There are 5 2s. Now this is 5 sevens. So it has 1, 5. It has again 4 आ रहा है, इसलिए यहाँ से भी एक 2 आ रहा है. So total we have 5, 6, 7, 8, 9. We have 9 number of 2s and we have 1. एक ही 5 है हमारे पास. हमारे पास एक ही 5 है. So considering this, we know only one pair of 2 into 5 will be formed, right? Therefore, only one trailing zero. So prime factorization will help us find the number of trailing zeros of any sort of multiplication. Do you get it how? Because we'll prime factorize and we'll find how many 2s and how many 5s are present in the given multiplication. Each pair will contribute to one trailing zero. You understand the base concept here? And it comes up from everyone? Yes? Yes. Chalo fir, okay. Do some questions, right? I'll give you, okay. Find the number of trailing zeros. Find number of trailing zeros in this multiplication. It is 21 into 24 into 35, 25, 45, 32. These numbers are multiplied. You tell me how many trailing zeros are there. Very good. इसमें बता करो. Yes. All right. How do we do this? We are like, okay, 21 doesn't bring either 2 or 5. This becomes 8 आता है, तो 2 cube. This brings 1 5. This brings 2 5s. This brings 1 5. And this brings so many 2s. Right? So overall, how many 2s do we have? How many 2s do we have? 8. And how many 5s do we have? 4. So how many pairs? 4 pairs. This means 4 trailing zeros. This is your answer. Similarly here, you have 5, you have 5, you have 5. But you have no 2 at all. 2 है ही नहीं उसमें. Therefore, 0 trailing zeros. There won't be any trailing zeros in 25 into 35 into 40. Perfect है? सही है ना? तो इस तरीके से हम prime factorization का use करके we can find how many trailing zeros a product has. Now we took random numbers as products. Whole point is, what if that product is given as n factorial? Who all understands what a factorial is? What is the n factorial? n factorial का क्या मतलब होता है? n factorial means multiplication of all numbers starting from 1 till n. Okay, example, 10 factorial means multiplication of all numbers starting from 1 till 10. That is what a factorial means. To start multiplication of all numbers starting from 1 till that number is called as n factorial. Right. So here, what they're asking you to find is, they are saying, okay, you find number of trailing zeros. You find number of trailing zeros in 16 factorial, for example. You find number of zeros in 16 factorial, right? So what do I know here? I know 16 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10, 11, 12, 13, 14, 15, 16. This is what I know, right? Now again, as usual, I'm going to find how many 2's and how many 5's are there, right? So here I know, okay, there is this 1, 2, this is 2 square, there is 1, 2, this is 2 cube, another 2 will be here. This is 4 3's are, this will be again 1, 2, and this is so many 2's. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. 15 2's we have. And how many 5's we have? 5, 1, 5 will come from here, 1, 5 from 10, 1, 5 from 15. So we have 3 5's. So how many pairs are becoming? 3 pairs only. Right? How many pairs are becoming? 3 pairs. But what is important to note here is that when consecutive numbers are multiplied like this, right? Power of 2 will definitely be more than power of 5. Matlab in the prime factorization of all the numbers from 1 to 16, definitely we will have 2 as a factor coming much more than 5 as a factor. Because 2 is a factor of 2, 4, 6, 8. Though every alternate number has 2 as a factor. Well, 5 as a factor will come at a jump of 5. 5, 10, 15, है ना? बड़े jump के बाद आएगा. So always, whole point is always in n factorial, number of 2's will be much greater than number of 5's, right? Do you understand this? Number of 2's will always be much greater in the prime factorization of n factorial. Number of 2's will always be greater than number of 5. Therefore, 2 into 5 pair, कितने pairs होंगे equals to number of 5's that are there. जितने 5's तुम्हें मिले उतने 2 into 5 के pairs मिलेंगे. Do you agree with me or not? Do you agree with this observation? Nitya agrees, Amrita agrees. You agree with this observation? Yes. So whole point is that whenever I have to find the number of, like, I have to find number of trailing zeros, equal to number of 5's in factorization. Correct? So whenever I have to find number of zeros in n factorial, I'm just going to find how many 5's are there in n factorial. Right? The more the number of 5's, the more the number of trailing zeros. So now the question becomes, ये तो तुम्हें समझ गया ना? ये तुम्हें समझ गया? Okay. So number of trailing zeros will be dependent on the number of 5's that are there. So now the question changes. The question becomes, you have to find the highest power of 5 in 16 factorial. This is what the question becomes. And अभी हम trailing zeros निकाल रहे थे, but trailing zeros से now the question has changed कि I have to find highest power of 5. मतलब how many 5's are there in the prime factorization of 16 factorial, right? Highest power of x in n factorial. ये question अभी बन चुका है. So how do you find that? ठीक है, how do you find that? Now understand the logic. What happens is, every time I write 16 factorial, where am I going to get 5 from? I'm going to get 5 from 5, 10, and 15. Yes or no? This is where I'm going to get 5 from, right? If I write 27 factorial, or let's say I write 21 factorial, where I'm going to get 5 from? 5, 10, 15, 20. Correct. So basically at the end of it, the number of 5's that are there depends on whatever number is given to you, 16. you divide it by 5 and take the greatest common integer. Do you remember greatest common integer function? Greatest common integer means greatest integer function. What is greatest integer function? That we have to report the integer value lesser than or equal to the answer that comes, right? This is the greatest integer function. So when I divide 16 by 5, you get 3 point something. 5 3s are 15, 3.2, right? So we will report only 3. So how many 5s are there in 16 factorial? 3. Similarly, here number of 5s are how many there? Number of 5s. Will be 21 factorial. Sorry. In 21 factorial will be 21 divided by 5, which is 4, right? So I can find the number of 5s in any factorial by dividing it by 5 and taking the greatest integer function. Correct or no? Correct or no? Getting the logic behind it? है ना? है ना? तो ऐसे तरीके से क्योंकि मुझे if I want to find trailing zeros, I have to find pairs of 2 into 5, and because it is a factorial and not a random multiplication, I know that number of 2s are always going to be bigger than number of 5s. The number of trailing zeros equals to number of 5s that I get, and number of 5s is basically this, dependent on this, right? But there is one more observation to make here. Let's say I do 27 factorial. So you get 5, 1, 5, second 5 from here, third 5 from here. 27 factorial is 1 into 2 into 3 into 4 into 5 till 27. So you have to get the number of 5. So you get it from 5, 10, 15, 20, and you'll also get it from 25. Whole point is this will give you 1, 5, second, third, fourth, and this will end up giving you 5th, 6th, 2 5s at the same time. It will end up giving you 2 5s at the same time. So whenever a 25 will come or any multiple of 25 will come, 50, 75, every number is going to give you 2 5s, right? So how are you going to account for that? You're going to account for that like this. The number of 5s or the highest power of 5. The number of 5 or highest power of 5 in 27 factorial or any number for that matter is given as 27 divided by 5 कर लो तुम पहले तो इसका greatest integer function निकालो 5 5s are 25 so 5 will come from here plus try 5 square also if the number is divisible by 25 1 point something आ रहा है so 1 extra 5 you're getting from there same if that number is divisible by 5 cube so the third 5 because that one number will end up giving you 3 5s so you're going to consider here which is not true here that's why the total number is 6. So if they had asked you what is the number of trailing zeros in 27 factorial, you would have said 6. In 16 factorial, the answer is 3. Here the answer was 4. Do you get this? Give me a yes or a no if you get this. Yes, you do get it. Very proud of you. So this is how you end up finding highest power of 5 in any number. And similarly, you can find highest power of any number in any factorial. Okay? Let us solve it. Okay, let us solve it and let us try to understand. Okay, so as I told you, interpretation जो मैं अभी समझा रही थी, the interpretation is following, right? So if you're given n factorial, right, and you have to find highest power of number x in prime factorization of n factorial. अगर मैंने n factorial को ये कर दिया, तो ये number x का कितना power वहां पे होगा? Prime factorization or any factorization for that matter. So this will be given as वो number n को तुम divide करो by x, वही number n को तुम divide करो by x square, वही number n को तुम divide करो by x cube, and so on you keep doing and the greatest integer function देते जाओ. ठीक है? These all are greatest integer function तुम देते जाओ. So this is the interpretation of the entire thing that we just saw. Okay, and it's time that we implement it. Once you write it down, we can go ahead and implement it as well. Very interesting application, no? Very, very interesting application. So when you find the power of 5, you get trailing zeros, है but apart from that, you can find any power, right? You can say, let's say, question is find the highest power of 3 in 10 factorial. Karo, find the highest power of 3 in 10 factorial. find the highest power of 3 in 10 factorial. Very good. So how do we do this? We are like, okay, I'm going to be like, I'll take 10, I'll divide it by 3. Then I'll take 10, I'll divide it by 3 square. I'll take 10, I'll divide it by 3 cube, and so on. Here the answer is 3, here the answer is 1, and from here it goes on to becoming 0. So there are 4, 3 raised to power 4 आएगा. देखो इसको टेस्ट भी करके देखो. 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. एक 3 यहाँ से आया, एक 3 यहाँ से आया और 2 3s यहाँ से आए. है ना? 4 3s बराबर. है ना? So what is the highest power of 3 in 10 factorial? The highest power is 4. Very good. Let us do find the highest power of 3 in 28 factorial. We are going to do 28 divided by 3 plus 28 divided by 3 square plus 28 divided by 3 cube and so on. So this is 3 9s are 27. This is 9 3s are. And this is 27 1s are. So this becomes 13. So what is the highest power of 3 in 28 factorial? It is 13. Correct? Are we sorted? Very good. Now, similarly, find highest power of 7 in 50 factorial. Highest power of 7 in 50 factorial. Yes. How do? You do 50 divided by 7 plus 50 divided by 7 square तक ही जा रहा है. Right? This is 7s are and this is 1s are. So total answer is 8. The highest power of 7 in 50 factorial is 8. Everybody is getting it. Nobody has confusion, right? Anybody has a confusion, ask me now. Everybody is getting it. Okay, perfect. Now what is the highest power of 3 in 145 factorial? You do 145 by 3. बेसिकली तुम्हें उतने पावर तक मल्टीप्लाई डिवाइड करते जाना है जब तक 0 नहीं आने लगा. तो 145 by 3 स्क्वायर भी आएगा, 145 by 3 क्यूब भी आएगा, 145 by 3 raised to 4 is 81 वो भी आएगा, 3 raised to 5 is 243 वो नहीं आएगा. तो वहां पे इट विल स्टॉप. So this is 48 plus 16 plus 5 plus 1 plus 0. So this becomes 17. Right? So number of the highest power of 3 in 145 factorial is 7. सही बात है. This is fine ना? ये repeat हुआ है. I will change the question. ठीक है? Whole point is यहाँ पे it helps you find trailing zeros also. It helps you find highest power also. But let us write some interpretations. Highest power of prime number p in n factorial, right? Highest power of अब तक 3 का 5 का 7 का ये prime factorials का निकाल रहे थे हम, right? So basically whole point is what does it represent? As a, like a summary or like an overview. What does it represent? It represents power of number p in n factorial का prime factorization. This is what we had been finding out, right? So this also means x raised to that power is a factor of n factorial. It means this or not. Matlab x raised to that power. Like for example here, if I'm saying the highest power of 3 in 145 factorial is 3 raised to 70. इसका मतलब if I'm going to take 145 factorial and I'm going to prime factorize it, I'm going to get 2 raised to something into 3 raised to 70 into 5 raised to something into whatever. This is how I'm going to get it. So whole point is 145 factorial is perfectly divisible. There is no remainder, right? This is a factor of n factorial. So if it is power, समझ गया ना? So whole point is it represents that it is a power x raised to that power, whatever answer is coming, is a factor of n factorial, right? What it also tells you, it also tells, basically it means that x raised to that power will completely divide and factorial without leaving any remainder, है ना? ये इसका मतलब, तो ये हमें समझना जरूरी, दिस इज द मीनिंग ऑफ फाइंडिंग द हाईएस्ट पावर ऑफ द प्राइम। ठीक है, ओके, ऑलराइट। तो वही से हमारा आता है, उसी के दो एप्लीकेशंस है कि वन इज व्हेन यू फाइंड द हाईएस्ट पावर ऑफ एनी नंबर एंड एट द सेम टाइम यू गेट टू फाइंड नंबर ऑफ ट्रेलिंग जीरोस। नंबर ऑफ ट्रेलिंग जीरोस मतलब बेसिकली तुम ढूंढते हो, ठीक है, कि 5 का पावर क्या है, वही के तुम्हारे ट्रेलिंग जीरोस भी आते हैं। सो देन इट बिकम्स बेसिकली 127 डिवाइडेड 5 प्लस 127 डिवाइडेड बाय 5 स्क्वायर प्लस 127 डिवाइडेड बाय 5 क्यूब। इसके आगे और नहीं होगा। Then this becomes 25 plus 5 plus 1, which is 30. Okay? And so this is it for this section. I want you to take this ahead with you. Okay? There are a little more small, a little upgradation on application of prime factors. क्योंकि आज तो मैंने देखा we solve. अच्छा, take these two questions as homework, okay? Apart from the practice test, of course. First is, ठीक है, a little more like this thing कि 137 factorial divided by 7 raised to n leaves no remainder. Find highest or maximum value of n. ये पहला सवाल, ठीक है। Secondly, I want you to find highest power of 9 in 145 factorial. अभी हमने highest power of 3 निकाला, अभी हम highest power of 9 निकालेंगे in 145 factorial. These two applications I want you to take as a homework. I will take another small class tomorrow, ठीक है, and in tomorrow's class we will upgrade over more applications, a little more applications of prime factorization, but largely we'll be developing into a new chapter overall, and that will be remainder theorem.